Hi students, it's Miss Culver again. This is our second video, 7.1b. I did notice on my first video, 7.1a, this was our first page, and this was my first time doing a video, so I didn't realize as I was writing along the right-hand side here that you couldn't see some of the writing. So if you want to take a minute, now you can see what I filled in the notes on the right here. Sorry about that. You could pause the video and fill in what I was saying, but that you couldn't see fully what I was writing. So again, we're looking at exponential functions, growth and decay. We got some basic vocabulary down through here, and we found the difference between what is growth and decay, and we looked at that below. So again, if you want to pause the video and fill in any words you might have missed. Okay. What we found is that an exponential function has an initial amount A, has a base B you are multiplying, and the variable is an exponent. So what is 7.1b today? That is where we're actually writing our own functions and using it instead of just looking at functions that were given to us. So here goes the notes. And here is 7.1b. I will be using a calculator quite a bit today, and so notice that they do on this sheet also, so I'm hoping to get you familiar with that. So an exponential function, growth or decay. Notice we said that an exponential function is you start with an initial amount A, and then you have a base. Now notice there's not a B here. Instead, there's a 1 plus R, because what we're going to be doing is writing the base ourselves. So this actually in the blue circle is the base. It's just we are going to be writing the base using 1 plus a rate. So this R right here is a rate, and it's usually a percent that you would write as a decimal. So notice then we had an X for the exponent, and they have a T here. We're still going to use an X on our calculator, right? But the reason why they put T here instead of X is because it's usually time, and they just want you to remember that. So that really is an X. So for an exponential function, we still do have an A. We have a base. We're just going to write it ourselves using 1 plus a rate. And our exponent is going to be time. Okay, and then that would be an output amount. Once we start with a certain amount, it grows or decays. Over time, we get a new amount here. Now, there's a little bit more I want you to know about R that I don't think is in these notes, and we're going to make that in red over here. So if you have growth, your R is going to be positive. If you have decay or decrease, your R is going to be negative. So you're always going to have 1 plus, but if you have a situation of increase, your R will be positive. And if you have a situation of decrease, your R will be negative. Okay, so what we're going to be doing is taking stories and writing an exponential function, because we know what these things are, in our exponential function, and then we're going to go ahead and use it. Now, there's a lot here that would help you on the calculator right here. We are going to do that together below. Okay, the directions say write an exponential function and graph the function to solve. Let's just write really quick what an exponential function is according to what they wrote above. A of t, you have some output amount. If you start with A in input, and you do 1 plus a rate as a decimal, and your exponent is time. Okay, they say it's measured in years. Okay, so we'll go with that today. Let's read the story and see if we can pick out our A and our R and go from there and write the exponential function. An initial amount of 40,000. Here we go. That's our A. 40,000, the initial amount. Increases, that's going to be a positive, by 8% per year. That's our rate, and we're going to use it as a decimal. In how many years? They're asking us about time. In how many years will the amount, that's the output amount, so that is our A of t or F of t, will our amount reach 60,000? So they're asking us to write a function here. Okay, I have everything I need. That would be my function equals my A times 1 plus my rate as time goes by. Notice I can add 1 plus 0.08 and make it a 1.08. So let's do that in red. 40,000 times 1.08 to the t. Notice if I'm going to put this in my calculator, this t is going to be an x. Okay, let's see. We wrote the exponential function and they want us to graph it over here, and then they want us to answer their question. So notice over here, notice that your x's are going from 0 to 10 and your y's are going from 0 to 80,000. That's a lot. So we're going to need to make sure we set up our window right so that we can see the graph that goes here. So let's do that kind of slowly. Here we go. Let's go to our y equals and let's clear out the function that we had, and let's put in our new one. 40,000 times 1.08 raised to the, we're going to use an x. There we go. Even though they use a t, that's just fine. Okay. Well, let's do a zoom 6, right? We're used to that. Well, when you do a zoom 6, go, well, I don't actually see anything. That's because your y's here are going from 0 to 10, and we need our y's, when you look at their graph, to go from 0 to 80,000. So let's go ahead and set our window. I'm pointing at the window button right now. Let's take a look. Let's see. Our x's need to go on our graph from 0 to 10. So 0 to 10. And the scale is 1. And we need our y's to go from 0 to 80,000. Don't forget that you have 4 zeros there. And now let's hit graph, right here. There we go. Now I'm just going to do a quick sketch of this picture. Right, so let's see where it's starting at. Let's hit trace, so we can see a little bit what's going on. Where am I starting? There we go. Okay. Well, of course I'm starting at 40,000. We knew that was the initial amount. Okay, excellent. Now, we know it makes a curve. Let's just take a look. Notice our graph ends at x equals 10. So let's go ahead and go there and see where our ending point is, and we'll just connect it and make a nice smooth curve. So one way I could do that is on the graph, I could go to trace, right? Or I could go to my table and take a look, right? So instead of graph, I'm going to do second graph. There we go. And I'm going to make my table go to 10, where x is 10. And at that time, my y is 86,357. So I'm going to graph that point, 10, 86,357. That's way up here. Let's just give it a smooth curve when we go back to the graph that we know that it looks like. Okay, excellent. Now, they did ask us a question. D, 3D. Approximate the time when the function is 60,000. Well, notice what they're saying is the time is the x on the graph. So they're saying about what time are you at a function value, a y value of 60,000? Okay, let's take a look. Let's hit trace. Let's go on over there. So let's hit the trace button and we're looking at the y. We're looking for y to be 60,000. That's the function value, and we're going to take a look at about what time that happens. All right, I'm getting close, just tracing along here. I'm at 59,000. Here we go. So y, or the function, is 60,000, about 60,000 at a time of 5.3 years. So here is my answer here on the left. Another way you could get this time, or this x, is like I just did a second ago. Instead of hitting graph, go to the table and look for 60,000. How close can we get to 60,000? Somewhere in between 5 and 6. So maybe 5.5. Notice that I think we were able to be a little bit more accurate by using the graph here. All right, I did add a note of my own here, number 4, because I want to make sure that you know how to do decreasing too. So what if 40,000 decreases by 8% each year? What is the function? And approximate when the value of the function is 10,000. So at what time does that happen? Okay, let's take a look. 40,000 is our initial amount. Here's our A. Decreases means that my rate is going to be negative, right? So that would be a negative 0.08 would be my rate. And what is the function? Okay. So that would mean I may need a little bit more room here. My A is 40,000. There we go. And my rate is 1 plus a negative 0.08. And my time is t. Now, I'm sorry, this is kind of small. I'm going to bring it over here and write it again for you. That decreasing exponential function is 40,000 and 1 minus a 0.08, of course, is 0.92 to the t. Here we go. Notice we said decreasing is decay, and our 0.92 is in between 0 and 1. Very good. Okay, now, so we wrote our function, and they want us to approximate when the function is at 10,000. Let's put it in our calculator. Let's clear out our other one. 40,000 times 0.92 raised to the x. Okay, let's take a look here. Again, notice if we do a zoom 6, we're not going to be able to see that. We need to have a starting amount of at least 40,000. So maybe we can use the graph that we used last time. Let's just hit graph. Let's see how it looks. We sure can. Now, I didn't ask you to graph it, so we're just looking at it. There we go. And they want to know, when is the function $10,000? So let's hit trace. And I'm looking for a y of 10,000. Let's just keep going. Let's find out about what time that happens. I'm at 21,000. Let's see if we can get down to 10,000. Looks like it's going to go off the screen. Will it go off the screen for me? It sure will. Oh, this is going to take us just a little bit. There we go. I just got that right cursor button down. I'm letting it go to 10,000. There we go. Let's see how close we can get. 10,000, maybe a little bit right there. 10,025. Wow, that happens after 16.6 years. Notice on the left, there's our time, 16.6. I'm gonna write that. 16.6 years. And there is 7.1b. Again, thanks so much for hanging out with me. I'm gonna take you really quick to meet my cat. Where is she? Going through my house? There we go. My beloved princess. Oh, there she is. She's sleeping. There's Princess. Isn't she awesome? Have a great day.